Firstly, thank you for all of you coming today. I appreciate you all taking your time out of your day to attend this presentation. I know a few friendly faces in the audience already, and most of you I don't. So for those of you who don't know who I am, my name is Rob King, and I'm a web performance expert at the NCC Group. And so what that entails is my day-to-day role is typically meeting with clients and learning about their problems and ultimately trying to help them make their websites faster. So I've noticed more and more of our clients that I work with going on journeys with regards to HTTP, and primarily that's the upgrading of HTTP 1.1 to HTTP 2. And for my own convenience, I'm going to be calling it H2, which is the recognized abbreviation for HTTP 2, which is what I will be talking about today. So a brief history of HTTP. The first introduction of HTTP officially came in the form of 0.9 in 1991. And back then, the landscape of the web was very, very different to how it is now. It was primarily just the transferring of files. There wasn't anything like there is today. In 1995, there was HTTP 1.0 released, and the web was starting to take more of a familiar feel, as in there was some text on a website. There might have been a couple of images as well, but still very, very early and very primitive. 1997 and HTTP 1.1 was released, and 1.1 primarily addressed the bugs and issues that were prevalent in 1.0. And then after 1.1 was released, we had a very, very long time with no releases whatsoever. And in that time, websites continued to get more rich in terms of presentation and more complex in terms of functionality as well. And while that's a great thing, the net effect of that in terms of speed and performance was that websites started to get slower. So in 2012, Speedy, which is a Google project, was released, and that attempted to address some of those issues, trying to speed things up on the web. And 2015, HTTP 2 was released, which essentially uses the Speedy template to, again, deliver websites in a faster way. So the issue with slower websites is that, so can I just actually have a show of hands? So who's aware already, who's already aware that a slower website is going to have a lower conversion rate and make less revenue? Who's aware of that already? Great, okay. Who isn't aware of that already? Okay, great. So exactly, so a faster website, more money, and that's why businesses care about it. They want to increase their conversion rate. And so with HTTP 1.1, as web developers, we really tried to make it work. We used lots of hacks and techniques to try and get the most performance out of HTTP. We did things like domain sharding. So we'd spread our content across multiple different domains in order to open up extra parallel connections within a browser. So most major modern day browsers, they support up to 6 concurrent connections per domain. And so opening up doing domain sharding would open up additional connections concurrently across that browser. We did things like image spriting, where we'd sprite images together. We'd put images together so to create one large image, and then so that was then one TCP connection to then download that image. It didn't require those additional round trips of downloading additional images. We did things like concatenation, where we'd merge JavaScript files together, merge CSS files together, to create that one large file. So we didn't have those additional connections to download that. And for the most part, these experiments worked. They did make our websites faster, but they weren't without their faults, and they did have issues. HTTP 1.1 even introduced pipelining, which again was an attempt to speed things up. So the way pipelining works is it allows over one TCP connection, the client and the server to send multiple requests without having to wait for the prior response to return. So multiple requests without needing that first response. And there was stipulations with that. The responses had to return in the same order that the requests were made, and also the responses had to return in full. They couldn't return in partial chunks. And the issue with that was that it produced something called head-of-line blocking. And so head-of-line blocking is when there are lower priority resources blocking the downloading of higher priority resources. And essentially that produced a bad user experience for websites. And in fact, pipelining actually had a net negative effect on speeding up websites. Websites actually got slower using pipelining, which is why pipelining by default is turned off in all major browsers, and it's unsupported by all major browsers as well. So what are our options? Can't we make better use of our bandwidth? Speedy, 2012. Again, it became that template for HTTP2. And for those that are keen to learn more about Speedy and the history behind that, there's an array of information online to be able to research that. And then HTTP2 arrived in 2015. And for the most part, it's been a great success. On average, HTTP2 is faster than HTTP1. Akamai recently did a study, and it showed that responses, on average, are about 20 to 25% faster to download on H2 when compared to 1.1. And so every website's different. There's always going to be outliers and anomalies, and depending on how it's implemented. But for most websites, HTTP2 is faster. So from a high-level perspective, nothing fundamentally changes. So implementing H2, it's not going to require any development work, any changes to the code base. The only difference with H2 is the way the data is transferred across the pipe, across the wire. So it's essentially it's the same protocol when comparing 1.1 to 2. It's still a request-response-based protocol, which is great. It's easy to implement. There's no development cost. And so a little bit more granular, how H2 works in comparison to 1.1 from a TCP connection level. We can see on the top 1.1, and so it's one TCP connection per object that's being downloaded, and that response type setup. And then H2 on the bottom, hopefully you can all see that. It's showing one TCP connection, and the data is then sent with streams and frames within those streams, and then it's multiplexed across the same TCP connection, which is, so it's one TCP connection per domain for H2, so it's a lot less TCP connections. And the way that it does that, as I mentioned, is multiplexing. So each request can be made immediately without waiting for the prior response to return. And the way that's different from pipelining is that the responses don't have to be returned in full, and they don't have to be returned in the same order that the requests were made. So it completely bypasses that head-of-line blocking issue that we had with 1.1. And so the stream is a two-way flow containing one or more messages. And a message is essentially, it's a request or response. And that message is then made up of lots of different frames, which are going to have different headers and datas encapsulating that. And so the way the multiplexing works from a stream level is that TCP connection, the frames can then interleave with each other and reassemble at the end by using the stream ID to identify which stream sent that data. So on the graph here, you can see stream 1 sending data, stream 3 headers, stream 3 data, stream 1 data. It's all interleaved with each other and then reassembled at the end because the stream ID is kept within that data. And there's a few more frame types than that in H2. These are some of the, I'd probably say the most important ones to remember. when looking at H2. So the data, the headers, and in addition to that, two of the more common ones are the priority. So the priority allows the stream to set a priority, which I'll get to shortly. Push promise is used for server push. So for those familiar with H2, that's what that one's doing there. Could I just have a show of hands? Who has heard of H2 before, but is quite new to understanding H2? Great. And who has heard of H2? They've actually worked with H2. They've got quite a bit of experience with H2. Cool. And who didn't raise their hand then? Okay. Okay, perfect. So header compression. So a really nice feature of H2 is the way it compresses headers, and it uses a compression mechanism called HPAG. And so the way HPAG works is it removes all the verbose header characters from the headers that are sent between the client and the server. And the way that it's so verbose, it removes all of the repeat characters. So it only sends certain header characters once, and then once it's sent it once, it doesn't need to send it again. And the way that it achieves that is that there's two tables, two on the server, two on the client, and there's a dynamic table which records all of the header information that's already been passed from the server to the client, and then the client to the server. And then instead of repeating that same header text again, it just uses the table reference as a reference, and it passes the reference instead. So then the browser can look up, oh, the server wanted to pass me this bit of header information because it's already referenced. There's also a static table as well, which contains a list of the most common headers, some of the most common headers that are generally used, general headers, which again can be referenced. And it's really powerful. So it tends to achieve about 85% in terms of compression, HPAG. And in 1.1, gzip and deflate are the standard compression mechanisms that are used. And the reason that they weren't used was because with Speedy, there was a hack on the deflate compression mechanism, which I think it was called Crime. And so it now enabled hackers to backwards engineer the data and uncover the data within HTTPS. So that's why HPAG was chosen, a security preference, but it also has turned out to be really, really good and very, very good at compressing. So server push. Who's heard of server push on H2? Cool, lots of people. So server push, a very powerful feature. It allows the server to push data, so to push objects before they're requested from the client. So the client's request might come in for that first HTML, and the server, if it's an H2 server and it's then intelligent, it's going to recognize that HTML, typically these style sheets are important for that above the fold rendering, that first rendering of the content. And these JavaScript files may be some images, and it's going to push them to the client early. It's going to push them to the client straight away. And what that does is it fully utilizes the client's available bandwidth. So if the client has a good amount of bandwidth and the HTML is only taking up part of that bandwidth, then pushing these additional objects are going to max out that bandwidth. And so when the client finally does download that HTML, it's going to have these objects stored, the client's going to have these objects stored in their cache already. So when the browser starts to parse that HTML, it's immediately going to be able to start using those objects and start rendering the screen quicker. It doesn't have to wait for the client to download the HTML, parse it, and then request those objects when it has it. The client's already going to have it. And server push really helps that first render. It's also, so on the right-hand side, it's pushing the style sheet before the HTML. So server push is also good for any HTML that does some server-side rendering. Server-side processing first. So any HTML that's going off to the database or it's doing some server-side processing to send in that time to first byte where there's no data being sent across the wire, to push the style sheets first, push the images first, and then when the HTML is finally ready to then deliver it, and then the client already has a lot of objects cached, is going to be quicker, the speed's going to be faster. And server push has been proven to speed up rendering times by up to 20 to 50%. And it's actually turned on by default. So most major browsers allow server push to be turned on, but it can be turned off. And the reason some clients might want to turn off server push is if they're using bandwidth restricted devices. So if they're using a mobile phone and they have a data allowance, that client might not want objects being pushed to it without requesting it. So it can be disabled, which is a nice feature, but it's turned on in general. So implementing server push, everyone should probably be using, will be making use of it. And it's considered better than inlining. So for those of you who remember inlining, and it's still something that we do to this day with 1.1, inlining the style sheets and the JavaScript into the HTML. So it's already there, and then the client then doesn't have to then request those style sheets and JavaScript file after receiving the HTML. It's already within that page. Was faster, but server push is even faster because those objects can then be cached. So with inlining, that code could not be cached, but because the objects will be separate and pushed up from the client to the server, then those objects can actually be cached, and so it's good for those subsequent page visits and repeat page visits. So prioritization and stream prioritization. With H2, the browser makes requests for the stream prioritization. So by prioritization, I'm referring to the amount of allocated bandwidth that each resource is getting when the browser is downloading that from the server. And the way that the browser weights those requests is it does a weighting, and it looks at the dependencies as well. And the weighting is primarily based on the MIME type. So HTML, CSS, JavaScript, and images, that tends to be the ranking, the order of highest priority on most major browsers. So HTML, CSS, JavaScript, and images. And so that means that images will tend to get less bandwidth than, say, a style sheet would, where that would get more resource when being downloaded. That said, though, the browser makes these recommendations, but ultimately the server has that ultimate choice, which is a little bit different to 1.1. So the browser might request that with the prioritization frame, but the server can choose to discard that and say it knows best and deliver other content. And this is a priority tree that the client would build. And this priority tree can dynamically change, and it works at runtime as well. So if I follow through a few examples, so the implicit route is at the top, which is the star, and then on the left-hand side, just got A and B. So there's no dependencies for them. They have no parents. They all inherit off the implicit route. And so the weighting comes into play there. And the higher the weight, the more resource that is going to get. So so B is going to get one third of the resource that A will get. On the second example in the middle, D is the parent of C. So D is going to consume the full resource before C. So it doesn't matter that C has a higher weight there. D is still going to get that full resource first. And then the final example on the right-hand side, D receives the full resource before C, and C receives the full resource before A and B, and then B is then going to get one third of the resource that A gets. And the nice thing about it working dynamically and running at runtime is that if the user scrolls down the page, so from above the fold to below the fold, it's going to send a prioritization frame immediately and update. So the content at the top of the page is then going to be less important, so it's going to be deprioritized, and the content below the fold, where the user's scrolling, is then going to get more resource within the from the bandwidth. It's going to get more bandwidth allocated. And also, if the user switches from one tab to another tab, that again is going to have that same effect. That tab is then going to get all of the resource, which I think is really cool. So that's an example. And so the example of prioritization in action, the example on the left is with, hopefully you can all see that. Can anyone see that? No, not really. Not the best font. So the example, let's see if I can zoom in. You can see that, right? Yeah. So the example on the left is without any prioritization set at all. And so everything is treated as equal. And the one on the right-hand side is with prioritization enabled. And so so you can see on the left here, some key images, some key style sheets which are downloading. And so 18.1 milliseconds, and on the right, 14.2. 69.9, and on the right, 22.7. So that's purely from turning prioritization on. And the same throttling, exactly the same environment, but the browser is weighting style sheets and JavaScript heavier. And so they get more resource over the images, whereas on the other one, everything's equal. And so it's all allocated equally. So H2 can actually be run over port 80 as clear text. It doesn't have to be TLS. It doesn't have to run over HTTPS, but really it does. And the reason it does have to is really is that the middleware on the internet, so the routers and the switches, they can get very nervous when they're seeing non-HTTP 1.1 protocol type traffic and then drop that traffic. And so because of the dropped traffic, the user then has a bad user experience. They're not able to get a good user experience. So for the most part, H2 does need to run over HTTPS so that TLS tunnel can then bypass that middleware, and the middleware then can't inspect that traffic and then choose to drop it. It doesn't know what it is. It can't see the headers. So for a good user experience, TLS does need to be enabled, and most modern browsers are going to require TLS to be enabled as well. So H2 can also, which is really nice, reduce weight on the back end. And by that, I mean the servers. So because a lot of infrastructure, a lot of servers are set up to allocate one process per TCP connection. And with that one process per TCP connection, if you're using H2, then that's just less resources needed to be used by the server. And compared to 1.1, where there's a lot of connections, a lot of TCP connections required. Having said that, though, if a website doesn't already have TLS enabled, that will add some slowdown. So if the website already has HTTPS enabled, great, H2 is a quick win, no 100%. If it doesn't, and HTTPS does need to be enabled first, then H2 still will outweigh that advantage and still reduce weight off the back end generally. So a common journey that a client has is they have a website, it runs over 1.1. How can they then go about re-engineering that website for H2? What do they need to change? What do they need to do to achieve that? And one of the key things is to actually undo all of those hacks and those techniques that we did for 1.1 to then speed up for H2, because a lot of those best practices no longer help and actually have a negative net effect in H2. There's also other things that clients can do, like routing. So the website doesn't necessarily have to have two versions. Akamai have some solutions, one of them called Ion, which enables it to perform depending on which protocol the traffic, so the client's browser is running over. If it's running over 1.1 or 2, it will then optimize the website on the fly, depending on the traffic that's been hosted over it. So the website doesn't necessarily have to be re-engineered, but most of the time that's the process that the user goes through, depending on the amount of traffic that, depending on the amount of traffic of the browsers that support HTTP2 would be coming from. So one of those best practices, as I alluded to earlier, is domain sharding, serving content from multiple domains at the same time. And the reason why that isn't very helpful with H2 is that H2 has one TCP connection per domain. So having domain sharding, have additional domains serving that content, is going to generate extra TCP connections, extra load on the back end, extra round trips where the client has to establish that TCP connection for that domain. And in addition to that, header compression is much, much less effective on multiple TCP connections. So HPAC only has visibility of a per TCP connection that it sits across. So if there's one TCP connection, then HPAC will generate 85% header compression across that. And if it's multiple TCP connections, then those headers are still going to have to be sent for it to build up the table. So it's working on each domain.
Very quick question. So it has a
Sure.
table per connection? Or two tables per connection?
Yes. Yep. So concatenation. So the combining of CSS and JavaScript files. Again, that's not ideal for H2. It's probably not one of the worst things, but it's certainly not the best either, because having larger files, having the client to download a large JavaScript file and then process that large JavaScript file on their, let's say, Android device is not an ideal situation. Android's not great with JavaScript, as we probably all know. So it's much better to have smaller files, so smaller CSS files, smaller JavaScript files, so the client can get something quickly and then get something onto the screen quickly as well. So for the browser to start rendering. In terms of increasing conversion rate and improving revenue, is much better to have from the array of run data that I have access to at the NCC group and with our real user monitoring tool, is been proven to show that a page that renders with some text but quickly, so it might have the logo, it might have some images, but there's some text, some image, some content that goes on the screen quickly, and then the page then builds. The user's much more likely to stick around and convert than a page which is blank for a long period of time, and then it all appears all at once. So that one large style sheet downloads, and then it all appears all at once. So that's why concatenation and CSS spriting are much the same. Those larger images are not as effective, and it's better to actually split up those JavaScript files, which is great from a developer's point of view because it makes the code more maintainable, and we don't have to run those development jobs before it's then released that then concatenate the files together. So there are some considerations for H2. And one of those is that low bandwidth devices, they tend to actually perform worse on H2. So for devices which don't have access to that much bandwidth, because they struggle to even download those 6 parallel connections in 1.1, having additional stuff that client then needs to download is just going to take more resource away from those important initial objects. So for above the fold rendering, there might be some HTML, a few style sheets and images, something that just the browser needs to display quickly. And so pushing everything all at once is only going to take away bandwidth away from those important resources. So what that has a net effect of is that the page load actually becomes slower in H2. So fast devices, H2, the way the internet's going, we're having lots and lots of bandwidth. Most people are on 4G anyway, but there are some people out there that have low bandwidth devices. Similarly, XP machines, they are not supported anymore. So i.e. on XP won't actually run H2 at all. And i.e. on XP, it might not even, depending on how TLS is implemented, it might not even run HTTPS either. So if the fallback from H2 is to 1.1, that also might break so that the user actually sees nothing. So it's not a quick win, 100%. And what I would recommend and urge any client before embarking on a journey like H2 is to check their real user monitoring data first, their analytics data, to look at the segmentation, to look at how many of their users are running over low-powered devices, low bandwidth devices rather, how many users they have on XP that use XP. I'm sure there's not many, but that use IE over that. And there are going to be some websites that are more tailored towards the younger generation where they have the latest technology, and there are going to be other websites which have more of an older clientele that have more low-powered, low bandwidth type devices. H2 can even help progressive web apps. So if it's the first load and the web service worker isn't primed with any client-side cache, then downloading that first load of the progressive web app over H2 is going to be faster. So that's another additional bonus. It will help with PWAs. And there's lots of CDN support already for H2. So Fastly, Akamai, and all the others, they all support H2. And there are certainly some considerations for CDNs in terms of H2. And one of those considerations is the CDNs like to be able to inspect the headers. And so uploading the TLS certificate to the CDN will enable the CDN to then terminate that connection and then to be able to inspect that data. And that, I believe that's typically what is required for the CDNs to work. So this goes up to Chrome 58, and the compatibility is only increasing. So we've got loads of browser compatibility for H2, loads and loads of support. And if for some bizarre reason a client is using a browser that doesn't support H2, it just won't upgrade. So the server makes the decision to upgrade. It attempts to upgrade 1.1 to H2. And if the client browser doesn't accept it, then it will just serve the website over 1.1. There's no difference. So decided we're interested in H2, and then the consideration is, well, how do I serve it? What server should I use? What hosting should I use? And there's certainly a few questions to ask before selecting the correct H2 server for your needs. And a few of those questions are, does the server respect stream and connection flow? Does the server have a good sense of prioritization? Does it support dependencies and waits? How does it have that prioritization as well? Does the server support server push? And does the server have intelligent caching? There are certainly quite a few H2 choices out there, and these are just a few of the providers of H2 servers. And to list a couple, so Jetty is a Java web server, and what Jetty does, which is a very nice feature, is it does something called intelligent push. So the server will learn what files the client has. So it does intelligent push. So it looks at the historical data of files which are requested from clients, and it looks at what dependencies those files have and what files are typically served to users when certain requests are made. And then over time, it then learns what the users want, what's pushed to the users, and then it will auto push those files ahead of time. So it doesn't even require any development effort. It just learns on the fly. It learns what users request, and it pushes that data. So H2O server, that has a feature called client cache aware. And so that will only push files, that will only server push files that it is sure that the client doesn't already have cached. So the issue potentially with server push is pushing content that the client might already have already. And so then that's wasted bandwidth. That's sending data and the client already has it. And so the way that H2O server achieves server push is by making use of cookies. And so storing the data in cookies and then only pushing data that it knows it hasn't got. Cool, we've got time for a quick demo. So let's have a look here. So I've set up a quick demo, and this is a website which I built really, really quickly. So it's just to demonstrate H2 and how easy it is to set up. So I created a self-signed TLS certificate and copied that. So for those, so this is a Java application. And those of you who are interested in Java, this is using Tomcat 9, JDK 8, and Servlet 4.0 specification, which is the requirements for Java to be able to support H2. And so I created a TLS certificate and key first, which I uploaded to the Tomcat server. And then to then set this up, the server XML file here, this was then commented out before. And then so just uncommenting that, which is just opening the connector port 8443.
If you show the code.
Oh, okay. What do I do?
Escape at the Windows key.
Cool. Nice. So this is looking at connector port 8443, and then it's just got a line of code to try and upgrade the protocol. So if it sees that the client's browser will support it, then to upgrade to HTTP2.
Zoom in a little bit.
Anyone know how to do that on a Windows? No. What's that? I haven't got a scroll here. My trackpad. Nope.
IntelliJ do Control Shift A and then zoom. No, Control Shift A, it'll bring up the prompt. Then someone will do.
Yeah.
And now type zoom.
Love it.
Cool. How do I use it?
I think it's an option you might have to turn on.
It's user friendly, isn't it?
And you can back, not Windows. So
Yeah. It's fine. Anyone that's interested in the code, just come and grab me while Pete's around, and I'll show you the code. It might take ages otherwise. So I've uncommented 8443 and uploaded the certificates, and then I've got a basic servlet, which is my server-side code, which is using the push builder class. So I've created a new push builder object. And then I'm pushing four files here. So bootstrap theme.css, style CSS, and these other ones here. So if I run that, it's running already. Cool. So let's put this over port 443. That's okay. Yeah. That's reassuring. Got to love a live demo. Cool. So let's open up developer tools, see what's going on. Network, so so it's going to establish the H2 connection, which we can see it pulling in here. So this is just a page with some text, and I think we should have some images as well down the bottom. Let's run that again, actually, but throttle it. So this is a broadband, a throttle broadband connection, 5 meg download, 4 meg upload. Let's refresh. Cool. So you can see here, so I pushed four objects and hovering over. So first of all, in Chrome DevTools, I can see the protocol level here. So I can see it's all running over H2. That's not, sometimes it's not turned on by default. And so just right clicking on that tab enables me to open that up. And in the waterfall, I can see I can see those pushed objects. So I can see when the browser started receiving the push, and then I can see how long it spent reading the push as well. And the objects that I didn't push is very apparent that they've taken longer to download on that throttle connection because there's no lag, and that's one of the great benefits of server push. And in Java, that's making use of the push builder Java object class. No. Please no. Cool. So finally, what does the future hold? And clearly don't know. Otherwise, I would play the lottery or something. But what I would predict is that there's going to be more frequent updates than we've had in the past of HTTP. I can't imagine it's going to take another 18 years for the next version of HTTP to be released. I hope not. Google apparently are working on a project called Quick, which is looking at the premise of serving UDP traffic over HTTP2. And that could well be the new HTTP3, possibly. So yeah, that was my introduction into HTTP2. Let's keep this conversation going. We're all in web performance together, this thing. We all like to make websites faster. So I'm on Twitter at the moment. I've just joined, so twitter.com, kingwebstring. Add me up. I'll be adding free content up there, articles. You can also send me any questions, and I'll try my best to respond to them in a timely fashion. I just want to say a quick thank you to Perry as well for all his time and effort in organizing these events. I can imagine it takes a lot of time, a lot of effort to do that. So thank you, Perry. If we could have a round of applause for Perry for just putting this together.